Okay, let's talk about why you shouldn't sacrifice your high school mathematics. This is the time to really learn math. So let's talk about that. High school mathematics is essentially for the average worker. If you have no plans on working in any scientific field, exploration of the entire field of mathematics is not required. But to survive in today's world, a basic education in mathematics is required. That basic mathematics education is given free of charge to you from 8th grade to the 12th grade. If you choose not to participate in this learning activity while you're in high school, your future employment will be severely jeopardized. Okay, why I say severely jeopardized? I say that because technology today has advanced society such that it is required that every worker have basic skills required to operate intelligent equipment, make intelligent decisions, and to communicate within an intelligent working environment. These jobs that still don't require this type of intelligence are manual labor jobs that have very low pay. The pay is low because the skill level required to do the task are low. These manual labor jobs have minimum requirements, such as you have to have the ability to stand, the ability to walk, ability to speak standard English, and sometimes that's not required. The ability to follow minimum directions. You need to have minimum muscle tone. You must have arms, legs, fingers, and average vision. So just about anybody can fill these manual labor jobs, such as working at a fast food joint or just doing manual cleaning, cleaning up an office building, cleaning someone's house, and so forth. Okay. When I was a kid, some 50 years ago, these manual labor jobs were held by teenagers after school and in the summer, mostly. The reason for this is that the standard of living was not as high then as it is today. Back then, a person could make a good living without a high school education. The most any worker needed was a pretty good understanding of a task and good common sense, because the majority of the tasks required muscle. But today, the majority of tasks on the job require mental intelligence because machines and technology do the muscle work. The reason for that is this. The highest cost burden on any business in producing a product or service is taxes and labor. Labor is the easiest of the two to remedy. If a worker can be replaced by a machine, the only cost to the business is maintenance of the machine. There's no social security payments. There's no retirement. There's no medical. There's no sick days. There's no vacation time, no holidays, no dependents, and no bathroom breaks. So with one machine, the business has probably replaced several workers. These several manual labor workers are now unemployed. For example, when I was about 14 years old, 3 days a week there was garbage pickup. The big garbage truck had two men riding on the back of the truck and one man was driving. One man would get the garbage cans on each side of the street and empty them into the garbage truck. The driver would then advance to the next house. Today, there is only one garbage truck equipped with a mechanical arm and the driver. The driver has a video camera that permits them to view the garbage containers for pickup. The garbage containers are special containers that are a requirement for all homes. These two manual labor workers riding on the rear of the truck are now unemployed. So maybe they got a job at a service station pumping gas. Well, service stations are not called service stations anymore because cars don't get serviced there anymore. They are called gas stations and they are all self-serve. The gas pumps are specially designed machines such that even a 16-year-old can pump gas into a vehicle. So that's another three people unemployed. Today, manual labor jobs are becoming more and more scarce. Furthermore, with the rise in the cost of living, the remaining manual labor jobs don't pay a high enough salary to maintain a decent living. Working at a fast food joint won't enable one to pay the high cost of rent, insurance, utility bills, and etc. These jobs pay the minimum wage because minimum skills are needed to perform the task. That's why you need a high school education in mathematics. It is the basic objective of every business to remove the high cost of producing their service or product to their customer. The less it costs to produce, the more profit the business takes home. Some businesses remove the high tax by moving their business out of the country or to a state with the lowest tax. When most kids take mathematics, they say they will never use what they are learning, and that's probably true or correct. Most of the English you learn in school you won't use unless you become a professional writer. And most of the mathematics you learn in high school you won't use unless you become an engineer or scientist or a mathematician. High school introduces you to the mathematics you should know as a basic human being living in an advanced society. If you choose to learn more, you have the basics to advance. Learning basic mathematics gives you the ability to do for yourself what you would have to ask someone else with an education to do for you. Okay, so now let's examine a basic example of high school math. And this is a very basic example, a project that you might have to or want to build on your own. This project would probably cost you $3,000 to $4,000, but you can do it yourself. Okay, let's do that. Let's look at that. Okay, our project here is we want to build a wheelchair ramp. So let's say that you're just a high school graduate and you need to build a wheelchair ramp for some reason, okay? And a ramp is essentially a triangle with special features, okay? Its slope is the special feature. You learn all about slope in the 9th grade algebra, okay? So here we have, let's say this is a porch, okay? This is the height of the porch. And from the height of the porch, we want to build a ramp for a wheelchair that comes down this ramp, okay? So the platform is where the wheelchair enters the slope, right here, up here, okay? And this is the wheelchair ramp, and this is the slope where the wheelchair will come down, okay? What's so special about a wheelchair ramp is that the slope, or grade, has to be gentle, or decline very slowly so that the person in the wheelchair does not roll down the slope at breakneck speeds. You know, if a person comes down this ramp, let's say it's an elderly person in a ramp, you don't want them to hit the bottom going 45 miles an hour. So you have to make this slope gentle. So let's investigate this. Okay, let's investigate what is grade or slope. Okay, let's look at a regular triangle, which is our wheelchair ramp. And let's say our height of our triangle is 5 feet. Let's say our porch is 5 feet high. Okay. And let's say initially we have steps coming down this porch, but we want to remove those steps or put the steps inside of the ramp. Have this ramp open on the inside so we can just slide it over the porch. And so the height of the porch or the triangle is 5 feet. And the length of our triangle, let's say it's 5 feet. Okay. So then we connect those two ends and we make a triangle, and now we have this slope. Well, if the height is 5 feet and the length is 5 feet, then what is the slope or the grade? Okay. Grade or slope, right here, grade or slope is equal to rise over run. You learned that in the 9th grade. So the rise is 5 feet and the run is 5 feet. So the grade is equal to 5 feet divided by 5 feet equals 1. Okay. And if we change that to percents, 1 change to a percent is 100%. So the grade or slope is 100%. Well, if a person entered this ramp, they would descend at breakneck speeds and probably be injured at the bottom of the ramp. So the angle theta of descent is what? Tangent theta is equal opposite leg over the adjacent leg. The opposite leg is 5 feet. The adjacent leg is 5 feet. So tangent theta is equal 5 over 5 is 1. Okay? And we take the inverse tangent of that 1, and that gives us 45 degrees on our calculator. Therefore, the angle theta of descent is 45 degrees. This slope has to be much more gentle to ensure safety. Generally, and I say generally, a descent angle for a wheelchair ramp should be 8%. Let's investigate this type of grade or slope. So let's say we want our grade or slope to be 8%. Since we know the grade is 8%, let's calculate the leg length of the triangle since the height is, say, to a porch of 5 feet. Okay. So as before, grade or slope is rise over run, but now we know the slope because we said the slope should be 8%. So 8% is equal to 5 feet, which is the height, the rise, over the run, which we call x because we don't know what it is. And we call it x because x is the letter for unknown, so we call it x. So we change percents to decimals, so 8 divided by 100, we change it to a decimal, and that's 0.8 equals 5 feet divided by x feet. Then we solve for x. We multiply both sides by x and divide by 0.08, and we get x is equal to 5 divided by 0.8, which gives us x equals 62.5 feet. And wow, to have a grade of 8%, the length of our triangle has to be 62.5 feet. And if we take the opposite leg, 5, over the adjacent leg, which is 62, now 62.5, and we divide that into it, we get tangent theta is equal to 0.8, and that's the grade, okay? And if we take inverse tan of that, we get our theta, our angle between the two legs, of 4.57 degrees approximately. So we reduced our angle from 45 degrees to 4.75 degrees. Okay, so anyway, this says that to decrease the grade to 8% requires that the length of the ramp be increased to 62.5 feet. That decreases the slope angle from 45 degrees to 4.57 degrees. What does that say about the descent? Let's say that once we entered the ramp, we moved down a height of 1 inch on a 8% grade. Then the grade or slope is equal to 8% equal to the rise or the drop of 1 inch. How far do we descend on run, which is x? Well, we do the same as we did here. We solve for x and divide by 108, change that to decimals, 0.8, and then we multiply by x and divide by 0.8, and it says x is equal to 12.5 inches. So in this gentle slope, when we advance 12.5 inches, we drop down 1 inch. And that's a very gentle slope, okay? And this is a gentle and safe slope. Okay, the next issue. You only have 40 feet of yard, but your ramp is 62.5 feet long. So what's the solution? The solution is let's divide the length of 62.5 feet into 3 parts and put each part side by side descending in opposite directions. So okay, here we have our porch, and we take the first part, 20 and 5/6 feet, and we descend down that ramp, come to a platform, and turn around, advance to another platform, descend down the next 20 and 5/6 feet to another platform, turn around, move to another platform of the last ramp, and then descend down that ramp 20 and 5/6 feet. Because if we divide 62.5 by 3, we get 20 and 5/6 feet. So that means we have 3 ramps. Okay. So at the end of each ramp, there's a 5-foot platform at the end of each ramp. What does this say about our descent? Well, if we know the height, we know the length of our ramps, which is 20 and 5/6 feet, but we don't know the height. So let's take 20 and 5/6 feet and multiply it by 8%, because that is our descent is 8%. Our ramp is an 8% ramp, so we multiply by 0.08. Okay, and we multiply 25/6 and 5/6 feet by 0.08, and we get x equal 1 2/3 feet. So for every ramp distance you travel, you descend 1 2/3 feet. And here we have it. So we have our entire porch height, which is 5 feet. And as you can see, we advance off our porch onto the ramp. And we come down the ramp to the first platform, and descend down the second ramp to the third platform, and descend down the third ramp, and we enter the ground level with our wheelchair. And so each descent height is 1 2/3 feet. So you have 3 ramps. Therefore, you descend 3 times 1 2/3 feet, which is, voila, 5 feet. 3 times 1 2/3 is 5 feet, which is the initial height of the porch. Another simple method of calculating the descent height for each ramp is to divide the porch height by the number of ramps. Well, the porch height is 5, and we have 3 ramps. So 5 divided by 3 equals 1 2/3 feet. I'd like to let you know that each of these calculations used here are 9th and 10th grade mathematics. Until next time, I hope you learned something.